where a lot of deployment of antennas are required, then that time this technology helps a lot in transmitting a signal via a transmitting antenna, and the same technology, if implemented at the receiver end, can be received properly at the user destination. So today's contents are, firstly, its introduction, then what are fading and multipath propagation, what exactly is a massive MIMO, and how this technology can be used for 5G and beyond 5G. Now, performance improvement using MIMO technology, and finally the conclusion. So let us now deal what is the prime need of this communication, wireless communication, because nowadays this wireless communication is in much demand. Higher data rates are required, quality of service, because daily at the fingertip. Is my voice audible? Is my voice audible?
Yes, ma'am. Yes, ma'am.
Okay. So quality of high grade of service, higher network capacity, then spectral efficiency and reliability. So whenever we are sending a signal from the transmitting end, if the signal is not reliable and if in between any noise occurs, so a lot of complexity is getting arised. Now, by using only fewer number of antennas at the transmitter side as well as at the receiver side, what happens? Two antennas will be kept at the transmitter and two antennas will be kept at the receiver. But there is not a single chance that the detection of the signal is taking place appropriately. So in order to get back whether the channel estimation is done properly or not, whether the channel is giving us information regarding the signal received or not, therefore a higher network capacity is used, and then only we can say that the signal is reliable. Now, spectral efficiency, it depends on the spatial multiplexing. Spatial means when we locate these antennas at different spaces. Now, suppose, for example, if I want to send a very important message from one node to another, and if I give that message to user-friendly destination, and let's say they are now diverting this signal to the other user destination of the receiver. But if in between, due to the complexity of hazardous building, then huge buildings, trees, monuments, the signal may distract. And because of this reflection, diffraction taking place in the form of multipath propagation, there is a possibility that we are going to receive the signal with some noise or with some error. And if it is not reached to the user destination within a specified limit of time, then the signal will be, or that reception cannot be called as a lossless or a reliable type of communication. Therefore, it is primarily needed to deploy large number of antennas, both at the transmitter side and at the receiver side. So by selecting these antennas and simultaneously sending the signal via different stations, then we can remove the complexity. But while implementing this wireless communication, there are so many restrictions. Firstly, there is a limited available bandwidth, radio frequency spectrum, because what happens if the band is quite wide open and we are using only a useful part of that band, but lot of the band which is specified, it is unused. So what if we are carry forwarding this unused band of frequencies, so in future you may not be knowing what sort of many more applications are going to be visible to us. So when we utilize the bandwidth properly, then and then only with the help of MIMO technology, we can deploy the signal to the user destination. So bandwidth plays a very, very important role. Then next comes the channel capacity. If the capacity of the channel is not holding the proper information, then capacity plays a very, very important parameter in holding the capacity and sending the signal via channel. And then depending on the complexity arises. Now, can you imagine in the air, electromagnetic waves, so many electromagnetic waves, so many mobile phones, they are simultaneously transmitting the signal and receiving. So what will happen? Because of the complexity, there will be a jamming, as the jamming is taking place on road because of traffic. So what we do? We have some signals. So as soon as we stop at the signal, then only some part of the traffic will be diverting, other will be restricted. So same thing happens with the signal in the air or space. So because of this complexity, we need to deploy some anti-jam margin algorithms. So these anti-jam margin algorithms are very, very helpful in removing the noise and removing the complexity, and then we can widen. If a signal is contaminated with ripples, if the signal is contaminated with noise, then due to this, the signal is not received properly at the user destination. And simultaneously, there is a multi-path distortion. Multi-path, so many signals being traveling together. So we need to take into account all of these restrictions so as to avoid the complexity in the signal. So this basically is the attenuation in the form of amplitude variation, which is experiencing some propagation delay. So due to this, if the signal is getting fade, then there will be a delay in providing the signal. So this fading may occur due to the geographical condition, or it may occur due to the atmospheric or temperature variation in the, which is regarded as a random process. So this will, the picture will be more clear to you if you look at the diagram. So from this figure, let me elaborate that the first figure is the non-line of sight and second one is the line of sight. Now, if two people, one people is sitting in one room, another is sitting in another room, there is a wall in between. Both are trying to connect with each other, but directly the signal is not getting transmitted from his or her cell phone to his or her cell phone. Firstly, the signal is sent to the base station, then base station detect the signal, and simultaneously the base station will then send this signal to the user destination. So can you imagine how frequently this action is taking place? And in this action, if there is arising any noise, then the signal will be degraded. So non-line of sight means if from the transmitting antenna, when the signal is diverted into the air or space because of building in between, because of mountains, because of trees, then there will be a non-line of sight type of propagation going on. So here you can see the transmission antenna is transmitting the signal simultaneously. There are 3 buildings and there are 2 houses. So simultaneously the signal is refracted because of this building. Then there is one line of sight. Directly the transmitting antenna is sending the signal and user destination is directly receiving because it is directly a line of sight. So whenever the system is working, because of the feeding channel, there should not be any attenuation which should be coming in between the propagation of this medium. Therefore, in order to avoid this multipath which occurs because of buildings, trees, and so many nodes. So if you can see, this A is a free space, B is meant for reflection, C is diffraction, D is scattering. So once the transmitting tower is transmitting the signal, but our receiver is not having that capacity of holding that signal properly, and we are sending the signal to abroad, to other countries. So previously, if you know, there was an application from the mobile network. It was called as Viber. So if you know, I think if you have used that Viber, there was a drawback. The signal was not getting connected directly. It was for the few of the second, the communication was taking place up to the mark, but as soon as some seconds were over, then there was arising a noise. Because of that noise, the signal is getting distracted and we could not hear the voice properly. So again, we need to connect it by using Viber. So what this WhatsApp did, this mobile network did, they have added one additional facility. Initially, the phone calling was not there in WhatsApp. Only Viber has implemented. So what WhatsApp did, he added conference, video conferencing, then telecommunication. By removing this all sort of errors which was not priorly recommended. So unless and until we deploy more number of transmitters and more number of receivers, both at the transmission side and as well as receiving side, then there is no guarantee that the signal will be recovered properly. And one more thing is there, whenever we are deploying number of transistors, a lot of complexity has to be there, lot of complexity is getting there, but there is a possibility that at the user destination our signal will be received with a noise free reception. So this is how, because of this multipath propagation effect and fading channels, there may arise some complexity. Let us now, this complexity can be avoided by using the massive MIMO. So this massive MIMO not directly come. Years of research went together, decades of research went together, and they came to the conclusion that by deploying multiple input and multiple output, transmitters as well as receivers will be helpful in enabling the technologies which can be anticipated for 5G and 6G networks and beyond. So the type of communication which is required, it uses a wireless channel. So if a proper wireless channel is used, then by avoiding the additive white Gaussian noise from the signal, the channels like relay fading channel, there is one more channel whose name is Raishan channel. So taking into consideration all these wireless channels and avoiding this complexity, this deployment of massive MIMO came into existence. So it can, because of the large obstacles between the transmitter as well as receiver, there is a challenge. So we need to give more emphasis on a massive type of MIMO technology. Now, we are using 4G. Now we are into the age of 5G. A lot of research work is going on. So while downloading a movie, or previously, whenever you are downloading, so you are supposed to download at least 10 to 12 images. So a lot of advancement was done, and simultaneously you can download 25 to 30 images. Then simultaneously you can download the complete video. But still there is a drawback. While downloading a file, a complete movie, it is taking some time. It is taking some delay. With a fraction of second, if this can be overcome, then we can say that the signal can be retrieved properly. So this can be done with the advantage of MIMO technology, like video chat, streaming, such activities like music. So therefore, this technology is helpful to the present generation. And deploying number of antennas, we are using a 5G new radio. So this 5G new radio can take the wireless communication to the next level, which we cannot think. If somebody would have given idea way back 20 years before that every person will be holding it as a rubbish idea. How come this is possible? Rickshaw wala, pan wala, sabji wala, each and every these vendors, roadside vendors, they all will be using cell phone, a mobile device. They all will be using a wireless type of communication medium for connecting. So that idea would have been considered as a rubbish idea, but now this is a reality. This is a reality. What we have seen in 2G, 3G, 4G, and now we are beyond. We are going beyond because so many applications are there. We are doing online shopping simultaneously. We have witnessed the scenario of pandemic. Without this technology, I think the lecture wouldn't have been possible. The faculty members wouldn't have taken their online lectures. So, with the advancement of this technology only, we could be able to connect to the people. So, can you imagine simultaneously so many users are getting connected, that to rural area, cities, countries, and the era of pandemic has witnessed, if a particular person is there whose parents are abroad. Now the school time it is in Nagpur, the lectures getting started, let's say 9 a.m. But if that fellow or this girl or a guy, if he moves to the other country because of pandemic, if he was in a position to move to the other country, but his schooling is there, so at night the timings are at night, and in India the timings are morning. So from their destination also they could be joined and attend the lectures because of this technology. What if the signal was not getting connected to abroad, and we could not able to connect to our family members who are staying abroad? Then the technology, it is beneficial for the society. If it is not giving anything to society, then such type of technology will not be a helpful one. So by deploying number of antennas, this 5G massive MIMO gives us a noise free reception. So introducing the concept of this massive MIMO, where the name implies it is an application of MIMO technology. So MIMO, I hope now you might have got the feel of what exactly is a MIMO. It is a multiple input, multiple output deployment of the transmitters and receivers for covering a huge network and a greater network capacity. So capacity also plays a very, very important role, because when we are representing any signal, that signal is always represented as a form of logarithmic scale, and the signal to noise ratio also plays a very, very important role. So if the signal is contaminated with the noise, and simultaneously with respect to some time, that error has to be removed, and in the form of bits, what actually we are doing, we are sending the bits in the form of digital pulses. These digital pulses are carry forwarded, encoded via some code words. Then these code words are deployed with the help of some specially designed antennas. So this technology is used in a specially designed antenna, and that term is called as a specially multiplexed MIMO. So I hope the brief regarding 5G. So for implementation of this MIMO, there are some beam forming channels. So while deploying the number of antennas at the base station, one more thing I would like to correlate here. If you go to some forest region, right? So due to the dense forest, there is a possibility that the signal is not getting recovered properly. And for downloading a particular set of file, we could not get the original form of the message or information. So therefore, at the forest area, if we deploy this technology by connecting more number of transmitters, by implanting more number of receivers using this MIMO, the signal will be recovered instead of dense forest, instead of fog, instead of any temperature or weather condition, any minus temperature degrees Celsius, we can detect the signal properly. So this hundreds of antennas element, can you imagine 100 of antennas element? They are connected together for spectral efficiency, so that the signal becomes efficient. So there is one 5G new radio massive MIMO, and this massive MIMO technology is the major keys in unlocking this 5G user experiences. And why this MIMO is getting massive? Because initially when the research started, only 2 antennas were deployed, then it increased to 4 antennas, then after increasing 4 it went to 8, though we were receiving the signal. But when we want to connect to a, when we want to cover a larger area or a broader space, that time there was arising some complexity. Therefore, when we increase beyond 8 by 8, 16 by 16 if deployed simultaneously within a range of 100 antennas, then systematically the signal will be getting properly. Now, this MIMO can be regarded as a multifaceted technology. So, and this type of wireless communication, it is used in mobile devices, networks, for multiple antennas to enhance connectivity and to offer better speeds and user experiences. What if nowadays, if you are not having cell phone, we feel like handicapped. So, roti, kapda or makan, and in addition to this roti, kapda and makan, additional data is added now. Internet, network, without this thing we cannot live. So these advancements make possible the improvements in the performance of 5G experiences consumers, so which will begin a new era. So let us now talk this massive MIMO, which is a user friendly. So it is using a spatial type of multiplexing. As I already told, spatial type of multiplexing. Multiplexing means we all go to movie theaters for watching movies. In Nagpur, there is a multiplex theater. For example, at Trillium Mall, if simultaneously 6 to 7 movies were running. At Pune, there is a megaplex. So it is a one common channel, one common platform. And through that common platform, simultaneously the signals are delivered. So multiplexing means though we are transmitting different signals, but via the channel, they are being multiplexed. All these signals will be multiplexed via the channel, but at the user destination, they are properly received to different. If there are 8 users from the transmitter, 8 users from the receiver, or 16 and beyond, then simultaneously each and every user destination will get back to the original information which was transmitted, irrespective of the noise in between, irrespective of the additive white Gaussian noise. So in order to remove this noise, we are making use of specially multiplex. So specially multiplex means it is related to space. These antennas are remotely located with respect to different spaces, so that by transmitting the signals via different stations at different times, the receiver will be able to detect the signal back. So here NR is nothing but the number of receive antennas and NT is the number of transmit antennas. And as I told you, the signal is represented in the form of as a logarithmic function. Therefore, a log scale is taken. And this logarithmic function is plotted in the form of signal to noise ratio. One more parameter is array gain. Whenever we are deploying number of antennas, so it will be regarded as a array of the antennas. So several antennas are used to transmit the signal, and then this several antenna in the form of NR-NT will significantly increase its spectral efficiency. So we can improve the performance of basic MIMO system by deploying more number of antennas so as to increase the coverage, then quality of service, which is primarily required. Then there comes the diversity gain. As I told you, I gave you the example. Instead of giving my important message to only one person, what I will do, the same message I am going to float to instead of selecting only one user path, we need to select greater than one, more destinations, so that other path will be carry forwarding this message or signal. So therefore, by employing diversity gain, it will increase the coverage as well as quality of the service. Now, one very important parameter is the multiplexing gain. When we use the parameter multiplexing gain, there will be an improvement in the performance, which will increase the spectral efficiency. Now, there are wireless channels. So for increasing the cellular capacity and so as to avoid the co-channel interference, because if the channel are going back to back, there arise the intersection of the channels, and due to this there will be existence of co-channel interference. So we need to reduce this type of noise, which is regarded as a co-channel interference. So now, why this massive MIMO is becoming reality now? Because we cannot live without the wireless communication system. My lecture, today's talk wouldn't have been possible if the wireless technology wouldn't have been in the existence. So since its inception a decade ago, this type of technology, it has evolved the academic idea to one of the hottest research topic in the field of wireless communication. Now in India, you might be seeing 20 years of conference or 25, but when you go to countries like Korea, they are running 108, 110 conference going on in the field of latest development of wireless technology, and we are totally unaware. We are totally unaware. They are deploying these standards. This technology is into existence in many countries. So the time for massive MIMO has come at this moment for two reasons. Firstly, we need to make the conventional technology, which has proven that it is unable to deliver a spectral efficiency. Because if the transmitting or receiving antennas are deployed at different user destinations, then there will be a noise in the existence of the signal. Therefore, secondly, the confidence in the exceptional value of the technology, which has spread rapidly since there are real life prototypes. Now, I already told you that we need to expand the spectrum. If there is a traffic jamming going on the road, so what we are doing? We are expanding the spectrum. So the same thing happens with the signals. So we need to expand the spectrum, spread spectrum. We need to change the spectrum. Modulation means change. So we need to change the modulation of the signal. So when we spread the spectrum, then there is lot of space, which is fulfilling for sending the signal as well as receiving the signal. And this is into the existence now. Therefore, this technology plays a very
तुमने एक बहुत ही क्लासी और एक्सक्लूसिव ब्रांड क्रिएट किया है, पर पिछली टीम ने उसके साथ इंसाफ नहीं किया। मेजा लवो को अगले लेवल तक ले जाने।
The diversity, because it is the basic concept which is applicable for deploying the number of transmission as well as reception paths. So as I earlier told, now diversity. What exactly is diversity? If any one radio path means a radio signal which is moving, which is getting transmitted from a one user destination to another. If that signal is getting a deep fade means attenuation is going to happen. Variation in the form of amplitude with respect to time. If such thing is happening, then another path has to be there which will have a strong signal, so that there should not be any disconnectivity between these two channels. And signal to noise ratio plays a very, very important role. By deploying this type of technology, we can improve the performance as such. So this is basically the diversity. The classification of diversity is based on time diversity, then frequency diversity, space-time diversity, space frequency diversity. So this type of technology is using space-time diversity. Space, different spaces, different destination, variation in the time, but the signal is getting back to the mark. So this is the diversity concept. It is using OFDM, orthogonal frequency division multiplexing. So what is exactly this? Whenever we consider such type of signals, these signals are regarded as a orthonormal basis function. Orthonormal basis function means these signals are perpendicular to each other, but they are orthonormal also. So while calculating these parameters, we need to configure what is the orthonormal basis function of first signal. If there are multiple signals, let's say from S0 to SM. So for each and every signal, we need to calculate its corresponding orthonormal basis function. And after calculation of this, then finally at the user destination, we will come to know what is the exact amount of data being recovered. So this space-time technology, this is the basics behind MIMO technology. So here we are using a time coding, which is simply using a linear processing of the filters. So if we use linear processing of the filters at the receiver side, then this filter, irrespective of the computational complexity, will be decoding the signal. It will be decoding the signal. So I hope you know University of Southern California. In the name of the scientist Viterbi, there is a Viterbi Institute of Technology, and these basic codes, they were developed over there. And we are studying into digital communication, the Viterbi decoding algorithm. So this decoding algorithm plays a very, very important role. And while decoding the signals properly as such, the minimum distance path is calculated. Minimum distance path is calculated. So if you look at the diagram, we are actually doing or increasing the diversity with respect to these space-time codes. So encoding and decoding plays a very, very important role at the transmitter level and also at the receiver level. So this space-time trellis code is one of the type of encoding algorithm. Second one is space-time block codes. So here we are using a block coding where the complex decoding can be done with the help of Viterbi decoding algorithm. And then only we can achieve the full diversity. Once full diversity is achieved, then our purpose is solved. So firstly, we need to transmit an information source. If the information source is not in the form of digital, we need to convert it. After conversion, it is given to a space-time encoder. After encoding, performing, implementing, encoding algorithm, the codes will be diverted via the transmitting antenna. So in the form of signal, in the form of electromagnetic waves, the signal is carrying the information in the form of bits. In between the channel, come whatever may be, building, trees, hazardous thing, the receiver is capable of receiving this signal. But still there are some lot of opportunities and challenges as far as 5G is concerned, and we are unable to deploy at our place, but lot of research work is going on in deploying at our place. So vision is, it's a promising key technology for 5G. So, and beyond. So in the past 2 years, you might have observed that this 5G type of commercial networks have been into much effect in hundreds of countries. And in the near future, what we can see, such type of networking technology can give us a superior performance, and the type of service which the user demands with latest application can be very well suited. So talking into terms of augmented reality, extended reality, these type of technology, they require high definition images or videos, and for sending a real-time data onto a particular set of wire channel, a high definition video can be the next Internet of Things scenario. So therefore, deploying number of antennas both at the transmitter and the receiver side, the mobile communication technology can be at an incredible pace. I hope you are getting me, all of you.
Yes, madam.
Okay.
Very nicely.
Thank you, ma'am. And now we need to increase the number of users. Before, the children were not using cell phone, but now can you imagine how many number of users are in use now? So what type of traffic is there in the form of electromagnetic waves, which may harm the signal, which may restrict the data being retrieved at the user destination? So this is the 5G major goals. The antenna, where we have deployed a 5G technology with which we can increase the speed, and then by implementation of a very useful parameter, threshold spectrum efficiency or network energy efficiency, mobility in the form of kilometer. Previously, signals were not able to detect if we are moving by plane, if you are selecting a mode like air. So we could not able to detect the signal at our destination with the cell phone. But nowadays it is possible. As soon as you take off, they give you the signal. Now you can restart with your laptop and mobile phones. Earlier it was not. Why? Because that time number of antennas were very, very less. But now we have deployed so that we can reach to thousands of kilometers. And what is the ultimate aim? If we are talking with our cell phone into the space, can you imagine how far the distance is? So by deploying number of antennas, we can get back the signal to any destination. So we need to use or utilize the bandwidth in proper manner. So therefore, for effective use of bandwidth and power and spectral efficiency, this technology is very, very beneficial for the society. So MIMO technology, basically beyond 4G, 5G and 6G, where we are deploying multipath propagation, there may occur a shadowing effect because of unavailability of the signal channel being received at the receiver. Now, let us now talk about what are the benefits of this massive MIMO. As I already told you, we can increase the coverage, we can increase the never before experience, which we never felt, and then increase the network capacity. And what more this massive MIMO can offer to us in the near future. So the type of communication, the type of network, the type of the mode of communication, it is going to change. It is going to change when we deploy more number of antennas. So such type of networks are expected to support a greater variety of wireless services. So nowadays, this subscriber, they're giving you that this is the additional facility. So many applications are there. If I want to run a program on the kit, right? If I want to run a program, what our students are doing, there is a virtual lab now. If our students are running a practical, nobody knows. But if he's performing online, the data is recollected. That data is captured, that data is noted down, that you have done so and so experiment at this particular set of time. This was the medium, this was the mode of channel, and you can perform at any time. The time limitation is not there. There is a specific timetable in our curriculum. There a bunch of students, 6 students, if they are performing practical, only 2 of them are serious, others are simply standing. And what we are doing then, we are taking their experiments, we are taking their test, which is of no use. The student, they haven't performed any single experiment. We are calling them for the viva, we are taking their exam. But on what basis? Do you know? The student, they have really performed the experiment or not, or they were simply standing and copying the readings. So therefore, the mode of transmission, the mode of reception in the form of wireless scenario plays a very, very important role. And then there is an ultra reliable communication where we can establish a very robust type of physical link. So physical link is established. So this is how we can maximize the diversity with the help of space-time codes. Then this is the LMOT scheme, basic scheme. LMOT, in the year 1975, this LMOT, Siavash LMOT, he did research and he found that there are some codes which we can develop for sending the signals, with which we can encode the message, with which we can decode the signals. And if proper use of transmitter and receiver is done, then we are in a position to get back to the signal. So this technology, it was into existence to other countries. And by deploying such type of technology, then we can find out its diversity order. So this is the structure of a STBC receiver. Here you can find a maximum likelihood decision. So maximum likelihood decision is based on the number of bits which are recovered. So there is a process, there is a decoding methodology. This decoding methodology will give you the information that from one node to another node, how the movement of signal is being traveling. Then from next node to third node, from third node to fourth node. So from one destination to another destination, there are so many different nodes. But crossing each and every node and using the attributes of physical layer, the signal is received. So there are so many different nodes. So finally the signal will be received first, who is eliminating all the complexity. So at each and every node, we need to calculate its maximum likelihood distance. It is in the form of a Euclidean distance. There is algorithm which is running behind this type of technology. So we need to calculate the distance at each and every node. So once the distance is calculated, then this distance will give you the message that at this node the signal is received, and then now we are into the next move. So suddenly from the next node to the third node, again there is a calculation in the form of Euclidean distance, and finally when the user destination receives the final amount of signal, there the final calculations are done. These final calculations are based on a matrix. What we are doing exactly? We are feeding this number of antennas into the form of a matrix. So if there is 8 by 8 antenna used at both the destinations, then we need to follow a 8 by 8 matrix. If 16 antennas are deployed, then 16 by 16 matrix. So for all these 16 antennas, they will be kept at different stations. 16 antennas at other stations. Then from one station, the first receiver will recover the signal. The signal which was transmitted from the second base station, receiver 1 will recollect. That means if we are using 16 antennas, so receiver 1 is having the capability of holding or retrieving all the signals. So can you imagine how much complexity is getting arised because of this juggling of this number of antennas, because complexity is getting arise when we are deploying more number of antennas. But final ultimate aim is recovery of the signal is very, very fast. So while making this calculation at each and every node, we need to calculate the Euclidean distance and then go ahead. So there is this algorithm, maximum likelihood decision, which gives us the minimum distance path. So for each node, we need to calculate the distance, and out of this complexity, finally we come to the conclusion that this is the minimum distance path where which the signal is reciprocated, reproduced properly. So as you can see the encoder, this is the diagram of the encoder, which is called as a space-time encoder, and number of antennas. So there is a bit stream at the input. This input signal will carry the bit stream in the form of bits. As we are dealing with the digital signal, these bits are in the form of zeros and 1. So it is a infinite bit stream which is carrying the information. But we are working on the useful part of the message where the information content is maximum. Therefore, then comes the concept of entropy. So what is entropy? It is an uncertainty because we don't know what is the exact amount of information present in the signal. So when we calculate the entropy, then we come to know that the average amount of information content per signal, per sample, per signal can be calculated. So there is a matrix. This is a channel matrix. You can see H11. So number of antennas, this ... specify more number of antennas. So transmitting the signal from first antenna, the receiver 1 will receive the signal. Same antenna is transmitting to different receivers at the user destination. So they are also having the capacity of holding the signal. So receiver 1 will receive the signal from all the antennas where the signal is being transmitted. Receiver 2 will also receive. Receiver 3 and n number of antenna will receive. But in between, because of this complexity which is getting arised, we need to calculate the minimum distance. So once this minimum distance path is calculated, then finally the number of bits where the error is occurring, that can be detected also and that can be corrected also. So by using this space-time coded MIMO system, we can calculate the minimum distance as well as the exact amount of information, as well as we can increase the capacity. So this is the coding technology. A bit stream is transmitted, a symbol mapper is there. This symbol mapper will map the symbols and accordingly it will generate a stream. So this stream which is getting generated is fed to an encoder. The encoder is responsible for encoding. So there is one algorithm going on. So this encoding algorithm will be fully implemented and in the form of code words at the output, the signal is being diverted. So this is the type of encoder involved in the MIMO technology. So now this maximum likelihood detection, what it does, it calculates the Euclidean distance between the received vector, and after calculation of this received signal vector, there is a possibility the signal will be getting modulated. So inside the modulator, the signal will be product modulated so that all the possible transmitted signal vectors with the help of given channel H can be estimated properly. And then we are in a position to find a minimum distance. So this algorithm is running behind this encoding operation and detection will take place at the decoding. So one thing I would like to tell you, because most of you are from the basic science as well as mathematics, and as the title is updation in the research as well as in teaching learning. So this is very, very helpful. Once we calculate this Euclidean distance and the minimum distance, then we are in a position to correlate the signal. So there is a metric. When we implement this algorithm, there is one minimum or maximum likelihood metric. So this metric is responsible for calculation of a path metric as well as a branch metric. So when these internodes are connected to each other, the transition which is taking place, it is called as a branch metric, and the final destination distance which is calculated, it is called as a path metric. So at each and every node, we have to calculate the branch metric and then finally the path metric. So this path metric will be summed up together at the final user destination, and then we will come to know what is the exact distance the signal has crossed. So the signal which has crossed the minimum distance, that will be mapped into the channel and receiver will demodulate the signal. After this demodulation is done, demodulation means detection. So what exactly we are doing? We call that the signal is getting detected. We cannot see the signal via our cell phone. Can we see the signal? We cannot see. It is invisible. The signal is invisible. Why? Because these are the electromagnetic waves. Your cell phone, if it is deploying such type of technology, it has the capacity of holding the signal. So once this distance gets calculated in the form of a particular metric, the final user destination will get the information that this is the minimum distance path where the signal has crossed from one transmitting antenna to another transmitting antenna. Though we say that it is employing a special multiplexing, the antennas are located at different stations, but while receiving the signal which has received fast, that is called the signal is received with loss of error. There is no error in the bit. And if it exists, if there exists some error in the form of some of the bits, like if I want to send a data like 1101 in the form of bit stream, I am transmitting this message 1101. At the user destination, I have received 1110. What does it indicate? It will indicate that the third bit and fourth bit are not received properly. They are received with error. If such thing happens, then receiver has the capacity, it has the tendency to rectify this error. So therefore, if proper decoding operation is done, decoding operation is done at the receiver side, we can eliminate these errors in the form of bits. After detecting and correcting the error, finally the same amount of information which was originally transmitted via the transmitting antenna can be demodulated properly. So therefore, this algorithm plays a very important role. So as I told you, there is a channel matrix. Inside the channel, we write down the Euclidean distance in the form of matrix. If there exists some delay, that delay will be represented by Ts. So finally, this channel matrix H1, then H2, if there are more number of antennas, 10, 20, 30. So the channel information is very well known to the input. Input here means transmitting side. If that information is known to us, then this algorithm will work properly and finally it will calculate the metric out of it. So here, when I say a signal is transmitted, let us talk now a signal which is represented as X. Now X is transmitted from the transmitting side. Or let us see a Y signal which is received at the receiver. What I am transmitting? I am transmitting a signal X. And at the receiver, the signal being received is Y. But what is Y? We should know. Y is the signal in the form of transition probabilities which will contain the channel matrix, the information of the signal as well as the signal itself. So this Y1 will be received as summation of all H1 X1 plus H2 X2 plus noise. Because in between the channel there is noise, it is received with noise. अगर बारिश आ रही है तो can we hear the noise of rain when we receive a call? What will happen if it's raining? You're talking to your friend and you can hear the voice of rain. So that type of signal is represented as a signal with error, signal with noise. So can you imagine if it's raining, we cannot hear. That type of noise can be removed and proper reception of the signal is being carried forwarded from one end to another. What if because of rain the signal is getting distorted? We are not into position to receive the signal. Then that type of communication will not play any role. It will not play any significance to the society. So because of rain, any hazardous situation, any atmospheric temperature, pressure, the signal has to be recovered properly. So many times it happens if there are clouds raining and if we are into a room which is at the corner, we are not in a position to recover the signal back. So what we do? We come out of the house, we move out of the room and then try to make the contact. Then finally the signal is getting connected. So still there exists a drawback in recovering the signal. Why? Because we have not deployed many number of antennas. The possibility is there. If we deploy more number of antennas at the transmitter as well as at the receiver level, then the signal will be received at any place, any destination. Whether you go to mountain, whether you go to undersea with the help of submarine. Optical fiber, previously what was said? Optical fiber, they are not containing the electromagnetic waves. We cannot pass the signal. The information cannot be retrieved. But now with the help of optical fiber, आपका internet सबसे ज़्यादा fast optical fiber से ही आ रहा है. And you might have deployed the optical fiber type of internet connection at your home so as to increase the range, increase the efficiency, increase the capacity, increase the speed. Because we all are in demand, we all are in need of a good communication system. So this is the algorithm of a maximum likelihood detection. Here we are calculating the minimum distance path and the vectors are specified into the form of matrix. And then by running this algorithm, multiplying both sides by equation, there is a Hermitian transpose of the channel matrix, we could able to get a maximum estimation of the signal in the form of ML decoding algorithm. So here this Q is denoting a slicing function, which is determining a transmit symbol for a given constellation set. Constellation here is in the form of antennas. We are talking in the form of antennas. And then we are in a position to decide on whether these vectors are being received properly or not. So this is the scheme of operation. Scheme of operation, we need to study the algorithm which is running behind this technology. So once the algorithm is known to us, we need to assign the parameters. After assigning the parameters, we need to do the calculation both at the transmitter side, both at the receiver side. Then what type of modulation scheme is involved, because these signals, it can be considered as a QPSK signal, PSK signal, like phase shift keying, quadri-phase shift keying. Depending on the type of signal employed and number of antennas, then final estimation can be done on the simulation, and then we can draw the inference out of it, that by deploying more number of antennas, this technology will do wonders. So as far as today's talk is concerned, let me summarize the lecture. So if more number of antennas are deployed, both at the transmitter as well as receiver side, this technology will do wonders. It will be regarded as a breakthrough invention, which can be brought forth from decades of research and then the development and unlocking of 5G to the mobile industry and beyond. And it will transform the world completely, connecting together. So therefore, this algorithm is very, very helpful. And I did research. There are different algorithms also, but there was some type of complexities getting arise. But when I use this type of algorithm, which is a maximum likelihood detection, we can able to cope up with the signal at a much faster rate by deploying more number of antennas. So as far as today's talk is concerned, I am thankful to all the faculty members. I'm thankful to the management LTJSS for giving me this opportunity. I'm thankful to Dr. Devashri Hardas madam. I'm thankful to Dr. Suvarna Savde madam and all the faculty members of physics department, as well as all the faculty, teaching, non-teaching, who are directly or indirectly associated in making this event a grand success. And the topic is very fantastic. Thank you one and all.
Very well said, madam. Along with roti, kapda and makan, mobile is also added in our lifestyle as a necessity. Thank you, madam, for such an informative talk on massive MIMO technology. We are very grateful for the time and effort you took to share your thoughts and experience with us. Now this session is open for discussion. I think no one has query. Thank you, madam. Thank you.
Thank you, one and all.
Thank you, BAGDE madam.
Very nicely
presented
madam.
the information.
BAGDE madam, very nicely explained.
Thank you, ma'am.
Next session is held at 2:30 p.m. where Dr. Bhumika Agrawal madam will guide us on changing needs of education system. All the participants kindly join at 2:20 p.m. Thank you.